All right, Algebra 2, we're going to work on complex numbers. And again, this is just more imaginary numbers and a lot of fun. So we are on lesson 6.8. And we are doing the complex numbers. And our essential question says, can you add, subtract, multiply, and divide complex numbers? So complex numbers, this is kind of a silly rule. It says equality of complex numbers, a plus bi. This is like the regular formula that we see in a complex number. So notice we put the imaginary at the back. But this rule is telling us it's equal to c plus di. And this IFF means if and only if AC, which makes sense, A and C, are equal and B and D are equal. Well, that makes sense. And we can add and multiply and subtract and divide complex numbers. So let's dive in instead of reading all these things that we could just look up in the book. Let's dive in. Notice example 1, we are adding 3 binomials. So notice I'm going to take all the real numbers and add them. Just to go back, if one of these plus signs was a subtraction, we would have to distribute. And then I'm going to take all the imaginary numbers with the sign in front and add those. So when I add, well, 4 and negative 4 cancel out, so I just get the real number 3. Negative 2, negative 3 is negative 5i, plus 7 is 2i. So this imaginary complex number is 3 plus 2i. Moving on. Notice on this one we are subtracting, and like I said earlier, we do have to distribute that. So I'm going to distribute this negative sign through to the 2 and to the 3. And I just take the time to write it just as is. Some people like to put the i's together, but I think you guys can probably see, oh, 3 and negative 2 are like terms, and negative 2i and 3i are like terms. So when I add these together, 3 minus 2 is 1. Negative 2i plus 3i is plus I. So it looks like that one is 1 plus I. Moving on to a little multiplication. When I multiply a binomial times a binomial, guess what I have to do? I have to FOIL. So just like regular, we are going to FOIL. All right, so first terms. 3 times 2 is 6. Outer terms, 2 and negative 2i is negative 4i. Inner terms, 5i and 3, and don't forget the sign goes with it, is positive 15i. In last terms, I'm going to erase all this so we don't get confused. Last terms is just 5i and negative 2i, which is negative 10i squared. But I know that an I squared is equivalent to what? Good, it's equivalent to a negative 1. So notice that this negative 10, well, negative 10 times negative 1, these will be positive, right? So when I add like terms, 6 and 10 is 16. Negative 4i and 15i is positive 11i. The last thing that I want to talk about in this section is this example of where we have to rationalize the denominator. So before we just had one I or one radical, but just like with radicals, I can rationalize the denominator by looking at the bottom. I have 2 minus 4i, so I'm just going to use the opposite, because I know when I use 2 plus 4i, the inners and outers will cancel out. Now remember, I can multiply anything through by 1 and not change its value. And so yes, we have to do both the top and the bottom of FOILing. So the top, 4 times 2 is 8. Outer terms, 16i. Inner terms, minus 6i. Last terms, negative 12i squared. Ooh, but I know that I squared is going to make this positive. I squared is equal to negative 1. Good. On the bottom, 2 times 2 is 4. Outer terms, 8i, inner terms, negative 8i, last terms, negative 16i squared, and again, I know this I squared is going to be positive. I also know that I did that to make the inners and outers cancel out. A positive 8i and a negative 8i cancel out. So on the bottom, it looks like I just have 4 plus 16, which is 20. And on the top, 8 and 12 is 20. And 16i and negative 6 is plus 10i. Now, can I just reduce these 20s? Absolutely not, because they are connected with an addition sign. So remember, on the top, we can factor out. I'm going to factor out a 10, and I have 2 plus I and 20. Now you can reduce. 10 and 20 can reduce by 2 on the bottom. So my final answer is 2 plus I over 2. Now, I'm going to show you one other thing just in case. Sometimes people write these as 2 over 2 plus I over 2, where this would be reduced to 1 plus I over 2. Now, I'm a smart girl, and I would take either answer, but I just want you to be aware of that, because on an SAT or ACT, I'll see this, and they'll say, hey, which one is not equivalent? And they'll show 1, 2, 3. They'll show all of these, and then they'll have a wrong answer. So just be aware of something like this, that you could show them either way. Usually 2 over 2 we would reduce to 1. Great job.